Hi everyone, I'm Jack Wagner.
And I'm Fatima Hazime. And then this is our project Intellitrash, which is a smart trash monitoring system. Okay, so for our usage scenario, our Intellitrash project aims to develop a smart trash can monitoring system that uses real-time sensor data and user-friendly GUI in order to prevent trash overflow, improve waste management efficiency, and promote cleanliness. The system demonstrates the feasibility of integrating IoT technologies for scalable waste management solutions across residential, commercial, and municipal applications. In a smart home setting, IntelliTrash would notify residents when trash cans are full and can be integrated with home automation systems. Meanwhile, in a citywide standpoint, IntelliTrash could be integrated with municipal waste management systems in order to reduce costs and improve efficiency through automated trash can monitoring.
For our system design, we are utilizing a Raspberry Pi Model 5 as the primary device for running the application and sending the sensor inputs over to the client. On the Raspberry Pi is a time-of-flight distance sensor that measures the trash can fill level through detecting the distance between the actual sensor itself and the closest piece of trash in the can. This sensor is connected to the Pi by I2C, and then the Raspberry Pi is connected to the home gateway through TCP socket connections. And once this data is transmitted back over to the client, it is shown through a graphical user interface, which we created using tkinter, and then we programmed both the server and client protocols in Python.
Okay. As for our protocol selection, we chose TCP sockets because it is straightforward, where there's direct communication between the Raspberry Pi and the client's computer. There's less latency involved due to minimal overhead of direct socket communication compared to MQTT's broker. TCP sockets allow for finer control over the system's communication protocols. And finally, there's current one-to-one communication infrastructure, which allows for more research efficiency, which is perfect for reduction of operating costs.
As for our non-functional requirements, in terms of latency, the average transmission time for sending the sensor data to the client is about 0.25 seconds. This is very relatively fast, and as you can see in the graph, over 109 reads, the rate of transmission is pretty solid at most points. In terms of reliability, we have near perfect packet transmission. The only lost transmission data comes from the client disconnecting from the server at the end, as there is no acknowledgement that the last piece of sensor data was sent to the client. So as a result, that packet was considered lost. As for energy consumption, we are currently relying on a 5-volt power supply to run the Raspberry Pi Model 5. When we talk about future works, we will mention that we're looking into alternative methods of not only the computer that we're using for the system, but also the power supply, just in order to ensure optimal energy costs and that we're not exerting too much computational costs than needed. And now we're going to go ahead and show you a demonstration of our system in action.
Okay, and finally, for our future works, we are aiming to transition from TCP sockets to MQTT for communication, which enables multiple clients to subscribe to the MQTT broker and then receive real-time notifications when a trash can is full. We want to use different sensors, such as the BME 680 digital temperature humidity sensor and a load cell with HX711 weight module sensors to increase functionality. We want to use single board computers such as the Raspberry Pi Pico Two, in order to reduce computational costs and power consumption, we aim to integrate a map API in order to determine and display the latitude and longitude of filled trash cans, which provides an intuitive way to locate them and display their statuses for both users and any third-party waste management services. And finally, we want to design an accessible and user-friendly application that adheres to established accessibility and usability standards, which ensures that the system is inclusive and practical for a diverse range of users.
That's all we have for this presentation. Thank you for watching.